And in our notes, I'm going to add to the solving equations note sheet that we have. And where we left off yesterday, we were solving radical equations. I'm going to add to that in just a moment. I'm going to add, a harder one actually for you guys, but I think it's a good idea to go over these again. If we want to solve this radical equation, our basic method is get the radical by itself, then square both sides and solve. So for the first one, I moved the 12 over by subtracting 12 from both sides, then squared both sides, and then just subtracted the 56 to the other side, and x came out to be 8. Don't forget, we always want to check our answers. Radical equations do have extraneous solutions at times, okay? And we did a couple examples here. The second example we did, we had an x in here, so that changed things a little bit, made it a little bit more difficult because when we moved that 1 over, we got x plus 1 on this side. So when we squared both sides, we then had to FOIL the right-hand side. So, not outside your wheelhouse, right? You guys can FOIL that. We just get a quadratic in that case. Once we have a quadratic, we moved everything to one side, factored. You could do quadratic formula, of course, and factor and solve. And in this case, notice that we did have an extraneous solution. So I'm going to add one more problem, which is going to be harder than those two. So are there any questions on those before I carry on? Okay, well, then I'm going to do one more radical equation. And this one is going to be a little harder. And I think you'll see why in just a second. Let's say we have the square root of x plus 1 is equal to the square root of x plus 2. Why is it harder? We have two radicals. Okay, these other ones, we only had one radical. So here's the basic idea. When we have one radical, we get the radical by itself and then square both sides. When we have two radicals, we do that same thing, but we have to do it twice. So get a radical by itself, square both sides, but then we're going to have to get another radical by itself and square both sides. So to start this problem, we do already have that radical by itself, so I'm going to immediately square both sides. I'm going to square that, and I'm going to square that. Now, the left side is where it gets a little ugly. I am FOILing the square root of x plus 1, and I'm going to write it all out. I don't always do that, but I think it's good for you guys to see it. I'm going to FOIL that out in my next step. I got to do square root of x plus 1 times the square root of x plus 1. The right side is easy. The radical just cancels, and I get x plus 2 on the right. All right, so let's FOIL this. Square root of x times square root of x is x. And then I have plus the square root of x plus the square root of x and plus 1. All right. So I had a radical by itself. I square both sides, and we're here. Now I have to do that process again. I have to get the radicals by themselves, and then I'm going to square both sides again. So to get these radicals by themselves on the left, I'll subtract x from both sides. And in fact, that's kind of nice that they actually cancel in this case. I'll subtract the 1 over, and so I have 2 square root of x on the left, and equals 1. All right, now I'm trying to get the radical by itself, so I will divide both sides by 2. And then finally, I'm going to square both sides. So the left side squared, of course, is x, and 1/2 times 1/2 is 1/4. Okay, and we should check that, right? I mean, so we have, let's see, if I plug that in here, that's going to be the square root of 1/4 plus 1. So I could, I could do that a number of ways, but one way that might be easy would be square root of 1/4 plus 1, and then do the right side. So I'm plugging 1/4 in here. So it's the square root of 1/4 plus 2, all under the radical. But I get the same thing. So it checks out. All right. So any questions on the radical equations? No? None in here. I'm sorry. I don't mean to cut you guys off at home. So please feel free to speak up at any time. All right. So I'm going to move along then to absolute value equations. So we're going to solve absolute value equations. And this goes kind of nicely with the radical equations because the process is similar. We're going to isolate the absolute value and then solve. So for our first example, let's take 3 plus 4 times the absolute value of 5x plus 2 is equal to 15. So I want to get the absolute value part by itself first. Then I'll show you what to do. So I got to subtract the 3 from both sides. So I have 4 times the absolute value of 5x plus 2 is equal to 12. Divide by 4, so I get the absolute value of 5x plus 2 is equal to 3. So I got the absolute value by itself. Now to solve it, think about this stuff that is inside of that absolute value. That stuff that is under the gray, that could either be -3 or +3, and it would be a true statement. So that's how we're going to write our two equations. We set that stuff that's inside the radical, so 5x, I'm sorry, inside the absolute value, the 5x plus 2, we set it equal to -3, okay, the opposite of that, or 5x plus 2 is equal to +3. And then that's an old algebra 1, right? Just move the 2 over. 5x is -5, and x comes out to be -1. So we get -1 and 1/5. All right, but let's check our answers, of course. So let's take -1 and plug it in there. So if I'm plugging -1, that's going to be what, -5 plus 2. The absolute value of that is going to be +3, right? Because it's absolute value -3 will be 3. 4 times 3 is 12. Add the 3, I get 15. It checks out. Okay, so -1 is good. Going to plug 1/5 in for x. All right, well, when you plug 1/5 in, remember the 5s will cancel there, and I just get 1 plus 2 inside that absolute value. Or again, the absolute value of 3, which is 3, times 4 is 12, plus the 3 is 15. That also checks out. So both answers check out. Be careful. Just make sure you do that when you guys are doing your homework. All right, so I want to do a couple of those just to go through a little bit of practice. So I'll do a similar one. Let's say 10 plus the absolute value of 7 minus 5x is equal to 11. So we want to get the absolute value by itself. I'm going to move the 10 over first. So I get the absolute value of 7 minus 5x is equal to 1. Now that stuff can equal -1 or +1. So those are my two equations. 7 minus 5x equals -1, or 7 minus 5x equals +1. I'm going to solve those. So I have what, -5x is -8, and x is 8/5. And -5x is -6, and x is 6/5. Of course, I'd want to check those. I'll save you the drama. They both check out in this case. But I want to get to another example. So, all right, we okay with these two? Any questions on those two examples before I get to another one, which is a little bit harder, not much? All right, well, let's then do one more. And so our last example will be the absolute value of 3x plus 7 minus 7 is equal to 4x. And the reason I say it's a little bit harder is because we got this x over here. So like when I try and get the absolute value by itself, I get the absolute value of 3x plus 7 is equal to 4x plus 7. That's not so bad. But now when I want to write my two equations, this stuff here can either equal the opposite of this or that itself. So when I write my two equations, I get 3x plus 7 could be the opposite of, in parentheses, 4x plus 7, or the 3x plus 7 equals positive 4x plus 7. So it's just a little tricky in there. But now those are manageable. We can solve both of those. So let's go ahead and do that. So I'll distribute that negative sign. Get my x's on one side. So I can see, so you guys are working away. I got -2 and 0 for my two possible solutions. I say possible solutions because we should check them. So I'll plug -2 in for x in the original. And I get the absolute value of 3 times -2 is -6, of course. And I'm trying to see if that is a true statement. Okay, if this up here is a true statement. However, it is not, because that's going to be +1 minus 7, which does not equal -8. And that means that -2 is extraneous. We got to throw that one out. Let's try the 0. Plug a 0 in for x, for the x's. So I get 3 times 0, which of course is 0. It looks like that one is going to work. So 0 is okay. All right, before I turn you loose on your homework, are there any questions?